The following presentation was recorded live at the 2015 National Bioneers Conference. To learn more about Bioneers programs and media products, visit www.bioneers.org.
Good afternoon. How's everybody? We're going to get started here. How's everybody doing today? What'd we think of Paul Hawkins' last talk? Is that amazing? One of the takeaways for me was more facts, the same facts, more facts isn't necessarily going to change things. So it's the story and it's the approach of how we do it. I remember I had an old mentor of mine, he said, Stan Russell, he said, John, what's the purpose of communication? He always asked me that. He said, to achieve the desired outcome. So we need to think about that. So my name's John Rulak. I'm the CEO and founder of Nativa and also co-chair of GMO Inside. And I went to the second Bioneers in New Mexico. I think that was like 1991. So it's great to see how it's grown so much. And so it's always good to be here at Bioneers. Can people hear me okay in the back? Okay, only okay?
Yeah, turn it up a little.
Okay, maybe you just have to be a little closer right here to it. Is there a way you can turn it up? Okay, we'll just be a little closer, yeah, good. All right, well, so we're gonna get going here on a presentation. A lot of information to cover here in an hour and a half. So I'm gonna kind of do the kickoff and intro, and then we're gonna bring up John Wick from the Marin Carbon Project, and I'm gonna hear a lot about what he's been doing. He's been a real pioneer in this area for the last 7 or 8 years, and even though I wrote a book on composting back in 1991 and studying organic agriculture, the understanding that soil can be the solution for climate change is so well hidden. Even myself didn't really understand that 2 years ago. And I just heard, so in the last year and a half, I've shifted my energy from GMOs and fighting Monsanto to now, how do we create this regenerative agricultural system? So, we're talking at lunch, it's kind of like mushrooms in a forest. Like a year and a half ago, there was like a couple mushrooms coming up in the forest of information as kind of a nature, idea. And John was one of those. Rylan from Kiss the Ground, Tom Newmark from Carbon Underground. And I looked around and I said, well, where are all these other people? Like, nobody else in the organic food industry is talking about carbon in the soil? Really? I'm not hearing those kind of talks, but in the last year, it's like now the network is starting to happen, and you're starting to see it all over. We had carbon tours. We had, who heard about the Soil Not Oil conference that we organized in Richmond last month? Great. How many of you were there? Excellent, good. So this is you may have heard of the quote, "The nation that destroys soil destroys itself," by Franklin Roosevelt. So I adjusted it a little and said, "The nation that destroys its soils also destroys its oceans." So today in my talk, I'm going to focus on soils and also its relationship between healthy soils and oceans. And that's a link that not a lot of people make, and it's a really, really important link. And then we're also going to look at why this current storytelling in the climate movement is not achieving the results that we need. And I wrote an article in EcoWatch a month and a half ago addressed to 350.org, Greenpeace, Sierra Club, about why 50%. The article was why are climate groups focused on 50% of the solution. So I'm a bit of a critic of the current climate movement. They're really important work. Let's try to slow down drilling for oil. We all know that's really important, but that's only 50% of the solution. We have to figure out a way to take that carbon in the atmosphere and pull it down. So a little about Nativa. One of the things, we're based here in Richmond, California. We sell organic superfoods, and one of the things I'm most proud about is we donate 1% of our sales to groups that promote sustainable agriculture, including Bioneers, and we're putting a fruit tree orchard at every public school in the city of Richmond, California. So we've given away $3 million to date. Thank you. So how many people know who Dr. Ratan Lal from Ohio State is? Okay, definitely you want to be aware of him. So he's a esteemed soil scientist, and this just shows you two ways of producing meat here with grass and then also industrial agriculture, which this confined feedlot is the biggest contributor to climate change and in agriculture. And if you want to see a future, please make a pledge. Don't eat any more CAFO meat. You know, if you're going to eat meat, if you're a vegetarian, that's great. More and more people are becoming, vegan or vegetarian or mostly. But if you are going to eat meat, definitely want to do pasture-based. And we're going to talk, and John's going to explain more about how his journey of not wanting cows and then adding cows and what happened when you take the cows off the land. It's very counterintuitive. So this is a great quote. A mere 2% increase in the carbon content of the planet's soils can offset 100% of all greenhouse gas emissions going into the atmosphere. Yeah, and some people say maybe that's 1.5% or 2.5%. There's a difference of opinion exactly what the number is, but in a period of 10 or 15 years, we can bring the CO2 down to 350 parts per million. We can do that. It's very doable. We just need to focus on it. Ironically, in Paris, agriculture and oceans are not officially on the agenda. Can you believe that? Oceans and agriculture are not, but there's starting to be some change. The good news is, guess who visited Dr. Ratan Lal in Ohio State and asked him a lot of questions and spent time? The French Ministry of Agriculture. And they're holding the climate talks in Paris. So there are things going on. I just met a senior fellow at NRDC 2 weeks ago, and he says, John, we're going to have this big event in Paris under the Eiffel Tower. He says, and it's called Human Energy, and we want soil to be part of that. And so I called up my friends, Rylan from Kiss the Ground. How many people know about Kiss the Ground? It's a great organization. Definitely Google them, The Soil Story. Watch that later. And so he's going to create a project there under the Eiffel Tower that around soil. So that's an excellent thing that's going on. So what are we doing? We're acidifying our way to ocean apocalypse. So I'm going to kind of go down into the descent of what can happen if we keep the same course. So, and I give this talk every couple weeks across the United States. It's not the funnest talk to give because it's something I love, the ocean, and we're seeing it become acidified, and the biological process is being disrupted right in front of our very eyes. And we have the solution, but will we act on it? That's the question for us right now. And luckily there's people like Paul Hawken and John Wick who've been focusing on this for a while and have a plan and have science. I like that. Trust in God, but bring the data. Yeah, the goddess. Trust in the goddess. There you go. That too. Yeah. Trust in whatever works for you at your core level, and bring some data also, because data is on our side on this soil story. So industrial agriculture is killing sea life, and we're going to get into why that's the case. And most people think that what's causing climate change is Chevron and Exxon. But the biggest contributor to climate change today is not Chevron and Exxon in the transportation industry. It's industrial agriculture, which is releasing more greenhouse gas emissions. But United States Department of Agriculture only shows that between 9 and 13% in the United States. It's way underreported. It's more like 25 or 30 or even more, especially when you take in how much they're clear cutting in the Amazon for cattle ranching, et cetera. So it's time we got to change our food system. So if we change our food system, we can protect the oceans. So this ocean genocide, oceans are becoming more acidic. Why? Because we're releasing so much carbon, both burning fuels and also from agriculture, and it's going in the atmosphere and then it's falling into the oceans. And what's happening when you put a lot of carbon in the oceans? They become acidic. So in the last 50 to 100 years, it's become 30% more acidic. And we are changing the whole face of the ocean. Now, the good news recently is the New York Times, which I've been telling people basically almost has like a hold or a ban on mentioning ocean acidification and really talking about this. They just did a major article 2 days ago and really laid out the challenges. And also, it's ironic, whenever they do articles on pasture-based meat or things, they'll have articles in Time or AP, and they never talk about carbon sequestration. It's really hard, like National Geographic, it's almost like there's a block out on this, but at some point it's gonna shift, and that shift is that's relying on us to be with our networks and educating people, and creating that effect where all of a sudden you could walk in the forest, you just see a few mushrooms, you come back 2 days later and they're everywhere. Why is that? There's this network, there's this right timing, there's like destiny, and that's what part of us who are in this movement are working on. So this is a great quote by Tom Newmark. Many NGOs view agriculture and carbon as the enemy, and that's the modern environmental movement today. Carbon is the enemy. It's bad carbon, bad carbon. But there's no more carbon today than there was 10 years ago or a million years ago.
Yeah, 10 million years ago.
Yeah, it's all here. It's like, is anger bad? Anger, how you display it might be bad, but you can take that energy. I used to be pretty angry about things. I used to be pissed about how corporations were destroying the world, and I'd lecture people and yell at people, right? And then I decided to channel that. So I'm using that anger, but it's like what we do with it. So the regenerative agriculture movement sees carbon as our friend and agriculture as our natural ally to help carbon return to the land. So we can work with farmers and ranchers. Instead of environmentalists fighting ranchers and agriculture like they're bad, and that's gone on, right? And how do you think they feel when they receive that? Right? Those damn environmentalists, right? And the good news is there's a lot of work on this. And so farmers and ranchers are excited about this and are starting to participate in this. Okay, I hope you're ready for this next slide. So this is a monster algae bloom that's taken over the Pacific Ocean. This was from August. This is 10 times bigger than the state of California. And they've never seen this type of algae bloom ever before. It's one of the reasons why they shut down the Dungeness crab season in Oregon and Washington. A dog in the Russian River recently died because he ate the algae. The ocean temperatures are higher from El Nino, but there's something that's going on, and they've never seen this before. So, also 10,000 sea lions have washed up dead in the beaches here in California this last year. The food change is changing. It's not just overfishing. It's not just plastic. It's not just chemical runoff, but it's becoming acidification. It's all of this. And ironically, a lot of the ocean protection organizations are not focusing on acidification. They're talking about overfishing, but overfishing is a big problem. But if it becomes too acidic, fish can't live in that, shells, et cetera. Washington State and Maine both have commissions on ocean acidification. So the message is starting to get through. So this is the land and ocean temperature that was taken in August. So what do you notice? You see all the red. This is like, the highest temperatures. It's the record temperatures, the dark red. And what do you notice off the North Atlantic? You see a blue zone. What does the blue zone represent? It's the coldest weather on record. So coldest water. Yeah, the water. So there's this giant there. Does anyone have any idea of why off the North Atlantic we're experiencing? Melting ice, yes. And 25 years ago, I used to read about Woods Hole research in the Northeast, in the United States, and they said there's a giant sponge off Newfoundland, this giant sponge, and when the ice water melted, it would go into the sponge and it would absorb. And it just kept absorbing and absorbing. Nature is very resilient, very powerful. And then they said at some point when that sponge filled up, the weather pattern as we know it in the Atlantic Ocean, that conveyor belt of Gulf trade winds that goes, and that will be broken, and we've just broken that now. So that system is no longer functioning like it used to. And We don't know whether it's gonna really go off this year or next year, but and you don't really. It's so well hidden. I didn't even know about this, even though I didn't even figure this out until like a month and a half ago. And I'm like, on a lot of different websites and things. It was the Washington Post did this article. Do you remember we had a little snow in Boston? So so what they're saying is Boston will be like Fairbanks, Alaska, and we're going to see the first kind of climate refugees in America is going to come from not from the oceans rising, but from the temperatures getting so cold in the wintertime. And we really don't know. And there's also going to impact the temperatures in the UK and also in Spain, because it impacts there a lot. So there's really looking at the story of climate change, or climate chaos, as Kenny likes to say. The current story is the planet's getting hotter, and solar and wind is the answer. And that's what the climate movement's been basically saying. It's going to get hotter, so solar and wind, high technology is going to solve it, right? Technology, it's all going to be good. But as Paul mentioned in his talk and other people, if you use a carbon calculator, if we follow the plan of the climate movement, NGOs today, and they're good people and they have so much pressure, they're like, corporations are suing them, they're harassing them, they're sending like people who don't even, who like work for them to try to like disrupt. I mean, it's an intense battle. They're trying to change this huge industry. So it's hard for them to go, okay, you're fighting this battle for many years. Now, wait a second. We got a new plan, John Wick and this carbon movement, we got a new plan. It's a little hard for them to like, okay, I'll just give up what I'm doing. I can barely even deal with that. Now I got to switch over to this other thing. But if we follow their plan, solar and wind will not be the solution. So all the whales and all the dolphins will be dead in the ocean in the next 50 years if we follow the game plan of Greenpeace and 350.org. If you just use a carbon calculator. And they're trying to do the best that they can, but now we have a way that we can change that plan. We don't have to go there. And the news story is oceans are becoming acidic, and we need to share that story, because when I talk to people who watch Fox TV, and I talk about climate change, they say, did you know it's not getting hotter? They're convinced of that it's not getting hotter, and they got the scientists to prove it. They're conservatives. They're smart people. They're not like stupid people, but this is their kind of way of thinking. And as soon as you talk to them about the oceans, and did you know the oceans are becoming more acidic, and how that's impacting the whales and the dolphins, all of a sudden they listen to you, and you're not talking about the information that they've been told is not true. Because Fox TV is not saying that oceans are not dying. They don't even talk about the oceans. So all we have to do, it's like a little child's got a toy, and you go, oh, don't play with that toy, don't play with that toy. And that's what we're doing with the climate movement. We're saying, don't play with that toy, don't play with that toy. How about just like, oh, look at this other thing here. Look at this, squeak, squeak, whatever, and then the child gets... Like, what do we want to do here? And Republicans they love the ocean. They like to fish. They like to travel all over. And we can't afford to have this division between, like the quote, climate, the people who are the environmentalists and then the rest of society, I mean, how about people in South Carolina? What do you think they think about climate change? Right? Yeah. So, but some of them are starting to think a little. So we gotta work on a different level. So the solution is, I like to say, with all these challenges we have, regenerative agriculture, it's our new app, and we can draw down carbon via pasture systems. We'll get into more of that. I'm just going to kind of go through these slides. I'm taking maybe a little too long on the political analogy there. Sorry. So there's basic 5 principles of soil health from Natural Resource Conservation Service, which John is working with, and they're part of USDA, and there's lots of really good people that are working with ranchers and farmers all over the country. So the good news is folks in Washington, D.C. get this, not necessarily at the top level and putting all their energy on, but there's lots of people who do, and they're working on these are tools available. It's an online resource that you can get. Compost and cover soil, that's really important. John's going to get into that. Plant cover crops, it's really important. Instead of using chemical fertilizers, we can grow. That's how, for instance, we get our organic hemp. We have our farmers for one season, they just grow alfalfa or vetch or whatever, and they fix the nitrogen from the air and put it into the soil. Non-organic, they just call up the chemical company and inject urea nitrogen fertilizer. And that has chemical fertilizer is like produces nitric oxides 380 times worse than CO2. So every time you buy non-organic, quote, natural, you're voting for something that's not a good thing. We need to minimize soil disturbance. So that's really important. We need to maximize diversity, more earthworms. I read somewhere that the pounds per acre of earthworms in a farm in Iowa versus that's certified organic versus non-organic, it's off the charts how much more. And earthworms till the soil. And what happens when it rains, when there's earthworms in the soil? The water can seep through. When they don't have the biological activity, it's like pavement, it just runs off. So it's just, really not. We need to slow the water down. And then we need to integrate some of the pasture systems and livestock. So recently, in the last month or two, I've been thinking about kelp, and I believe kelp. And there's not a lot of research on the internet, so it's like I kind of feel like I'm this pioneer looking at this. But I think kelp could be one of the best solutions to climate change in the world today. Because what is kelp like? It only needs one thing, CO2. It likes carbon dioxide, and it can grow very rapidly, and it can deal with ocean acidification temperatures and the environment. So kelp has interesting potential. There's a group called Green Wave in the Northeast that's just doing some research on this, and no one's really doing that much. There may be some. I haven't spent a lot of time researching that. And it can also be a cattle feed. So kelp's got a lot of potential, and we need to research that more. So I'm going to talk a couple campaigns. This one we did on Starbucks. So GMO Inside is one of the groups that we have a couple 100,000 Facebook fans, and we were the ones that got Cheerios to go non-GMO. This was a campaign, Starbucks Destroy the Sea. So when you buy a latte, understand what's going on there. Acidification of sea life, just so you can take this away here. Acidification is destroying sea life, and we can attribute the problems of oyster hatcheries to the increased carbon in the ocean. So we really got to do something here. Here's some, if you're interested in some of the articles, I'm just going to wrap up here. You can go on EcoWatch or also SlideShare. You can see some of my slides, or you can also follow me on Facebook. So I'd like to, like you imagine a healthy ocean. We can do this and you go forward after today. Think about what are your actions? How are they going to impact the health of the oceans and the health of the world? I'm going to bring up. Going to ask John to come up here and let me just get your presentation here. Yeah. All right. John Wick from Marine Carbon Project.
Thank you. Thank you. I have to find my place here in relation to the microphone. Could we turn those lights down? Is that possible? Anybody in this room see a light switch that we could play with? You gotta be a little louder. Okay. Louder. Okay. Outdoor voice coming up. I am John Wick. I'm a neighbor. I actually live 20 minutes from here, west. This is my ranch. And on this ranch in Nicasio, we created the Marine Carbon Project. And that's what I'm here to talk to you about today. The ranch is on Lake Nicasio. It's a reservoir. And in 1958, in our county, we determined that water was more important than milk. And so at that point in time, the 5 dairies that were in this valley were flooded. And the little island you see in the foreground here was where the milking parlor and the dairy were for the ranch that I operate. And all of the surrounding land went fallow and then ultimately was leased out for beef cattle operations. When my wife and I took over the management of our ranch in 1998, we came to it as leave it alone wilderness enthusiasts. And we were confident that if we left these natural systems alone, we could create wilderness and that the landscape would heal itself. So we entered into our management by removing the cattle that were on the ranch. There was a young man leasing our grazing rights, and we evicted him, and he removed his cows. And in a very short time, just a couple of years, our ranch fell into chaos. By removing grazing from this system, the coyote brush started encroaching on our hills, and soon our beautiful grass fields were a weedy, thatchy mess. And so in 2003, when we really recognized that we'd done something that wasn't what we were expecting, we reached out to a scientist, and this is Dr. Jeffrey Creek. He's a PhD rangeland ecologist. Jeff is a systems thinker and quite wise, and he was the first one who also came into our ranch and found something good. Everyone else to that date had come there and said, oh God, you have this, kill it. You have this, kill it. All we were doing was killing things, weeds and different plants. Jeff found native perennials and was quite excited about this. And Jeff suggested that we declare our management objectives and then develop a strategy on how to manage this watershed. It's 540 acres. It's an entire watershed. It goes from the GGNRA up on the ridge all the way down to the reservoir, and there's no real outside influence in this ecosystem. So it's a perfect test bed to try some ideas. But we had to think about what we really wanted for the landscape. And we're birders, and we thought perhaps that creating ground nesting bird habitat would be a good thing. We had a few meadowlarks up on the high meadows. And so we said, okay, Jeff, let's make ground nesting bird habitat. How would we do that? And so Jeff basically had us get a bit of an education. He suggested a lot of reading, and in that reading, I became aware of a significant difference between the annual plants that dominated our system. These are the oats that came with the Spanish in the 1500s. And these oats put all of their energy into seed production. It happens in a very short period of time. They grow quite tall, and not being from here, they actually germinate sooner than the native plants do, and they outcompete them. So here we have a system that's dominated by an exotic plant, and the native plants, which are several of them are perennials, are quite amazing. And Jeff had found a few of these on the land. And you can see by this image here that these native perennials put a lot of energy into below ground root development. And they do this so that they can be safe against fires and droughts. And so there's a lot of carbon energy stored below ground in the root tissues of these native perennials. And that if we used some kind of a management practice that promoted the deeper rooted perennials, we might be able to achieve our management objectives, which was creating ground nesting bird habitat. So one of those strategies, it turned out, much to my dismay, was cattle. And so we gave a lot of thought to this, and I was really, I'm pretty headstrong in a lot of ways, and there's no way I'm going to bring cows in here. I just know they're bad for the environment. So we looked at elk. The GGNRA has a herd of elk. We talked to Don Neubacher. We actually started to arrange importing elk from the seashore. We ran into problems with Fish and Game around doing that. We looked at sheep and goats. We do have a resident mountain lion, so that wasn't such a good idea because of predation. So we settled on cattle, and we had to find a herd of cattle that I could borrow as a management tool to promote ecosystem function. That's an interesting conversation to have with ranchers. We did find a herd, and this is a herd that doesn't use dewormers, and they haven't for 35 years, because the last thing I wanted to do was introduce an element into our ecosystem and deposit a biocide into the soil system. So we found a large herd of Hereford Angus beef cattle, and decided to import them once a year as a disturbance, an intentional disturbance. And what we do is we wait until the cliff swallows arrive, and it's usually around March 18th, March 20th. This is in the time of the year when the soils have started to dry. There's still enough moisture that the birds can find the mud to make their nests, but it's firm enough that we don't have pugging or compaction from the hooves of the animals, and we bring them on. And interestingly, the flies that follow the herd are the favorite food of the cliff swallows. And now all of a sudden I'm starting to think, what have I tapped here? There's a bigger, deeper, longer term pattern here. It's very interesting. And so in our discussions with Dr. Creek, how am I going to manage these cattle? It's an intentional disturbance in the system. And so the idea was to concentrate them and move them through. And the idea was, and this is just speculation, but the idea was that perhaps historically, these grassland systems that I'm managing had co-evolved with large herds of elk who walked through the landscape following peak fertility and left. So how, as a rancher, am I going to take 250 cows and create a 1 million head herd? One of the ways is to concentrate them, and I've played with several different innovative fencing and containment strategies. The cows actually love this. It's a rolling electric fence, and when I pull up in my truck and I start pulling it out, they get quite excited because they know that they're going to get a fresh bite of grass that no one has stepped on or pooped on. The calves always seem to get through it. I don't understand that. I've let them go. So as a rancher now, what I'm using is cattle as an intentional disruption or a tool to promote an objective that I'm looking for. And so when in the year I bring them, how many I bring, how densely I mob them, how long they're in the field, and then the period of recovery are the variables that I can work with. This fence, on the left side of it, the cows were in that field for 8 hours and then pulled off, and that's the total grazing for the entire year. And within 1 week, you can see the regrowth occurring. Now, this happens because cows basically have their favorite plants. And if you allow the cow to stay in the field, they'll keep revisiting that perennial plant and they'll eat it until all that's left are the oats or the less desirable plants. So your management strategy actually can inform your biomass population. So our strategy was to promote the native, deeper-rooted perennials, and it worked. Within a few years, we were starting to see whole fields, acres of native plants without planting a seed. This was becoming amazing to witness. The cows are very easy to work with. They're quite cooperative. They come to my voice. I do it all by myself. I walk. I call them. They come. I moved them 67 times in 5 weeks. It's the hardest I've ever worked and the most fun I've ever had. And we've become quite a community, and we're collaborating on this. So these are professionals at this point. And what we do is we basically walk through my landscape, and then they leave. And what they leave behind is really amazing. So I've basically achieved the wilderness that we thought we were achieving by removing the grazing impact. And we've done it with the introduction of a scientific or a theoretical framework upon which this all might be happening. There are a couple interesting questions here, though. It takes me 4 semi-trailers to bring the herd on and a 5th one to haul the herd away after 5 weeks. Now, this is interesting. That's 50,000 pounds of animal weight from eating grass that didn't exist 6 months before. What's going on here? What does this mean? And I've actually written that up there. But the point is this. By removing the grazing, we're seeing an amazing regrowth. This is a measurement. By having cows removed from the system, we were able to measure 3/4-inch recovery of a Danthonia plant within a week. So the grass bounced back. In that process, the disruption, the plants actually can't support the root system. They slough root tissues into the soil system and then regrow with the carbon stores in the roots. And all this time, Dr. Creek was getting more and more excited. And he was saying, think of grass plants as little straws that sip carbon from the atmosphere. And if you think about green plants and some phytoplankton and other organisms on the planet, only plants make sugar from thin air. This is interesting. And the cows like to eat that sugar. So my job as a rancher is to grow grass. And then animals eat that, and then they produce meat, milk, wool, or other products like that. So Dr. Creek had also been working on several other projects. The McAvoy Olive Ranch, most of you might be familiar with. On that system, he'd been working for over a decade, and he increased his soil organic matter from 1% to over 12% by doing grazing management and compost application. That's a significant increase, especially if you start to comprehend that all that carbon in soil organic matter, half of soil organic matter is carbon, and all of that carbon came from thin air. So this is exciting, Jeff, now. And at this time, it was about 2007, we were seeing this success. Fairly recently, Governor Schwarzenegger had signed into law the Climate Solutions Act, AB 32. And Jeff was suggesting that if, in fact, we were increasing durable soil carbon, we could create carbon credits that were being discussed as cap and dividend or cap and trade as a result of the AB 32 legislation, and we could get a new revenue stream to land managers to keep them on the land. They were experiencing a lot of pressure from development, and the idea here was if we were doing something that was beneficial to the climate, was improving environmental health, could help solve some agricultural problems, that perhaps we could do a carbon trading strategy. But what we needed was a way to measure that increased carbon. So we reached out to University of California at Berkeley and met Dr. Wendy Silver. Now, Wendy is a biogeochemist. She's amazing. She's an atmosphere soil gas exchange scientist, and she's a world-renowned soil carbon sequestration expert. And we posed our question to her: is my grazing management increasing soil carbon? And to our surprise, and it really was a surprise, she said, I doubt it, and I doubt we could measure it. Now, this is interesting. So I had to know what's going on. She helped me get a little bit of an education. She is a professor. Measuring bulk carbon is not the whole story. Soil carbon, which is what we're asking about, actually is on a continuum. Soil carbon ends up in different buckets in the soil system. Soil carbon has different residence time depending on what form it's taking in the soil system. Most soil carbon is temporary. It cycles through rapidly, which is a good thing. However, in those processes, some of the soil carbon can end up being more durable. It can end up in a physically protected or chemically protected form and can last much longer. The majority of this image is the organic carbon, and you can see plant tissues, but the little corner image is the more mineralized carbon, and that will last for millennia. It's a long-lasting carbon. So to revisit that, most soil carbon is actually in plant tissues and in the bodies of organisms. Most organisms in the soil are looking for carbon to eat, and when they find it, they eat it, and they respire it back to the atmosphere. So carbon cycles rapidly through these soil systems. This is rangeland systems or arable systems, all soil systems where there's vegetation, this is true. So most soil carbon is very temporary. It can cycle in minutes or days or months, but it does cycle back to the atmosphere. However, in those processes, when microorganisms are eating plant tissues or each other, some of that free carbon in the system can accumulate. It's sticky. And when that happens, you get occluded light fraction carbon. And this is interesting carbon because when this occurs, the soil electrical property changes, and now drops of rainwater that were passing through subject to gravity become particles of water detained in a plant-available form. There's tension around these root zones when there's carbon present. Now, rainwater is held in the soil system, and that's a good thing. This carbon can last for decades. And likewise, and it's purely a matter of circumstance, that free carbon loose in the system during processes of microbes eating plant tissue or each other, those microbes or their waste products can become chemically bonded inside cracks in clay particles. This is heavy fraction carbon, and it's permanent for our purposes. It also holds more water, and it's a good thing. So just to revisit, Dr. Silver is saying, I doubt you're increasing the more recalcitrant fractions of carbon. It's most likely exciting the system, and it's cycling and going back to the atmosphere. So for your climate solution question, I doubt it, and I doubt we could measure it. But Dr. Creek had been measuring soil organic matter increases, and he'd been seeing a biomass response that suggested there was more water present in the system. So here we have two different scientists with opposing positions. This is actually good news because that tension can create good research, and that's what's happened here. So for my own education, and I think you guys are most familiar with, green plants produce oxygen and moisture. And for those of us who saw Paul's remarks this morning, he showed us the stomata in that image. It was quite beautiful. When those stomata open to release oxygen and moisture to the atmosphere, CO2, which is a gas under pressure, rushes in and fills that leaf. And then under the sun's energy, the plants pull in soil moisture and soil minerals from the soil system. And these minerals are the nutrients or the waste products of microbes around the root zone. And under the sun's energy, in photosynthesis, the plants convert all of those to sugars or carbohydrates. And this is one of my wife's favorite lines. All of the carbon and carbohydrates comes from thin air and nowhere else. I had never thought about this, but had I thought about it, I probably would have said, well, the carbon comes in through the roots, like the moisture and everything else. It's the opposite, and that's what our inquiry started to look at. So it turns out that this transformation of carbon, this movement of carbon between carbon pools, atmospheric carbon dioxide is transformed into biosphere carbohydrates through photosynthesis. And so this carbohydrate now can enter the soil system or the rhizosphere, which is the digestive tract or the immune system for plants, by 4 pathways. One of them is the root tissues themselves are carbohydrates. And as I described earlier, during grazing events and other plant events, the plants slough root tissues or they're eaten by organisms. Now that carbon is in the soil in a different form. Plants exude a tremendous amount of sugar all around every surface of every root. 40% of the sugar a plant makes is exuded into the soil as sugar to feed the microbes who are then the digestive tract and the immune system for plants. And there's also a wonderful association with mycorrhizal fungi. The plants gift sugar in exchange for nutrients. It's a great relationship there. And the fourth pathway is the natural accumulation of surface litter. This is plant tissue, manures, dead bodies. And over deep time, soil systems have developed a whole range of solutions or systems that bring that carbon and nitrogen slowly into the soil system. And Dr. Silver was, her background was tropical forest ecosystems. And so grasslands were a new question for her. And so she looked into it a bit. And it turns out grasslands are really significant. Grasslands, or grasses, occur in grasslands. Grasslands are in rangelands, which are mostly grass, some brush, some trees. They are the single largest cover type on Earth. And these systems are the default cover type. These occur where there's not adequate rainwater to support a forest. So grassland systems have developed strategies to transform atmospheric carbon into soil carbon, where they have carbon reserves to tolerate drought, fire, and things like that. So these grassland systems are part of rangeland systems. California has a significant amount of rangeland systems. And globally, it turns out that they're the single largest cover type at 3.5 billion hectares. Most of them are grazed, either intentionally or by resident populations or migratory herds. And now Dr. Silver is getting interested because our question is my grazing management increasing durable soil carbon? If that were true on such a vast landscape, potentially that would have a climate benefit. So in order to ask that question, we had to know, what are you starting with? What's your baseline soil carbon level? So in 2008, around January, we organized all of the Marin County agricultural agencies, organizations, and institutions. And we created the Marin Carbon Project. And this is a list of the partners. Our website is marincarbonproject.org, and you can find bios on all of our partners. And so organizing that group allowed us to have access to 35 dairy pasture and beef pasture operations in Marin and Sonoma, where we went in scientifically now and measured to a meter deep existing carbon levels, and we found some amazing results. These soil surveys included bulk density pits, and so we had a pretty comprehensive biogeochemical analysis of 100 years worth of management in these systems. And in the process, the lab technicians picked out all of the root tissue, and through soil carbon fractionation process, we eliminated the labile fraction, and we're only looking at the two more recalcitrant fractions. And we found something that surprised Dr. Silver. We found a broad range of carbon levels in these existing managed systems from 30 to 150 roughly. And when we looked statewide or in the entire region, it turns out Marin County soils were pretty consistent with how the state soil profile was. We fall about right in the average there. Our soil survey found 30 to 150 tons of durable carbon in these systems. Dr. Silver wanted to know what happened on those high carbon sites. What's the history there? Those sites had had wet dairy manure applied to them. The other ones didn't. Wet dairy manure application, though, has a tremendous greenhouse gas emission profile with it. We have methane, nitrous oxide emissions, and those are far greater than any possible carbon benefit. So we know that application of dairy manure has an emission profile, but this is the first time a biogeochemist had ever looked at the long-term results. Ranchers do it because they see grass grow on that spot for many, many years. So it's a good thing for them. They get rid of a waste product, they see long-term grass growth, and nobody's actually been tracking the emission profile from it. So to date, it was an accepted local strategy. When we looked at the data, what we found is that the carbon was actually occurring in the more recalcitrant fraction. This is really important now scientifically. This is so important that Dr. Silver sent the soil to Michigan and had it carbon dated, and we found something that was really amazing. In 1996, the French deployed a nuclear device near Australia. We found massive quantities of 10-year-old French carbon a meter deep in Marin County soils in a permanent fraction. Whoever, that was great, right? This is exciting news. You could stop the day with that one. What we have shown scientifically is we can transform atmospheric carbon and get it into the soil system in a durable form. There are emissions associated with that, but our question was, could we replicate this scientifically? Dr. Silver, and this is a quote of hers here, we were looking for a needle in the haystack. She didn't think we could measure it and it wouldn't be significant. We were looking for a needle in the haystack and we found bricks. So what we now needed was a scientific way to test this idea ourselves without the emissions. And so after a lot of discussion, we ended up looking to compost. Now, it's really important here. We were not proposing putting compost on grazed rangelands. This was a pure science experiment now. Could we intentionally measure increases of carbon from a topical application of an organic amendment? That was our thinking. We picked a 1/2 inch thickness just because we wanted enough that we thought we could measure, but not too much to cover the plants. We designed a set of research plots on my ranch and up in the Sierras. These were randomly assigned treatment and control plots. We also looked at other treatments, which did not pan out in the end, and I'll talk to anyone later about those. But our thinking was that if we put compost on grazed rangelands, we should see some kind of results from that. Prior to any compost application, UC Davis came and conducted a complete above-ground mapping exercise. We knew what plants, where they were, how many of them. Prior to any treatment, we did extensive soil sampling with bulk density pits. We knew the complete biogeochemical properties of these systems. We knew everything about the compost. And then we started a campaign of measuring with the infrared gas analyzer and other more sophisticated lab equipment. We were measuring the CO2 emissions, nitrous oxide emissions, and methane emissions. We installed temperature and moisture probes to 30 centimeters. And we pretty much had a handle on everything going on as a baseline prior to any treatment. And then on December 8th, 2008, on my ranch, and then just, I should have said, we took the whole experiment, 3 blocks of plots with replicated 3 times with controls. We took the whole experiment to the Sierras and duplicated it. By doing that, we bracketed California's Mediterranean rangeland system. 61% of the state of California rangelands are Mediterranean. We have a coastal prairie system here, and we went to a Sierra foothill, which is the other extreme. So we had different grazing management, different soil type, different climate, different grass. The same exact compost was found in Sacramento. This is an urban green wastery. I'm an organic ranch. I needed to find an organic OMRI certified source. So we found a compost there that satisfied, and we hauled it both directions across the state. And on December 8th on my ranch, December 12th in the Sierras, we put 1/2 inch of compost on 3 blocks of plots with controls and then let the system run for several months. And in that period of time, each of us grazed our systems differently. I had a specific management objective for mine. In the Sierra site, they put about 35 head in 30 acres for 3 weeks, whereas in my system, I put 250 cows for 8 hours in 3.75 acres. And after several months, we went back in. This is about May, and we looked for the results. What we immediately were able to show was that the composted sites had a much higher emission profile. There was certainly more CO2 emissions from that, and that makes sense. We excited the system. But what we also found was that the forage production was significantly higher of what has turned out to be a more nutritious grass. So we're getting 50% more production of a more nutritious grass from a single bump of compost compared to the control. And then for our purposes, we measured a significant amount of carbon coming in the durable forms. It's very exciting results. And this graph here shows the occluded light fraction and heavy fraction carbon quantities at the different depths. Very exciting data. We then continued for the next 5 years and measured the same thing without any further compost. Every year on its own, the system took in another ton of carbon per hectare. So I'm going to repeat that because this is the best news of the day. A single application of compost knocked the system, and if you think about general systems theory, we had homeostasis and then an event, and now the system is self-organizing to a new normal. That new normal is exciting. It's holding more water, producing more grass, and taking in more carbon on its own every year. We sent the data to Colorado State University, where they have the Century model. They ran our data and suggest that this phenomenon will continue. I'm going to say this really slowly. A 1/2 inch application of compost one time will result in 30 to 100 years of soil carbon sequestration. Pretty good. Who knew? Did not see that coming. What that looks like, this is actually a printout of the 1,000 runs of the Century model showing the norm. The thin line that's declining is the compost carbon. So we see that is now slowly degrading over time. But what's happening that's so exciting is the photosynthetically derived atmospheric carbon is now transformed into durable soil carbon at that rate there, that cloud pattern. And the time signature, if you go out 30 years or so, we're still seeing significant carbon in the system coming in on its own. This is really good news. the other thing that the model showed us is that perhaps a 1/4 inch would have done the same thing. Now remember, this was a research project. We were not thinking agronomic rates of application, which is about an 1/8 of an inch per acre in terms of agriculture. We were trying to do something we'd be able to measure. The model shows that it would take half that amount of compost to get similar results. We gave our data to the hydrologists from the USGA up at Sacramento. They got quite excited about the idea of managing for carbon, and they've done a big poster. This is more complicated than you can see here. But what it shows as we enter a period of climate water deficit, which is what we're seeing now, increased demand for a reducing resource, by increasing soil carbon, we could actually offset the loss of the Sierra snowpack. The amount of water we can hold in our soils statewide by managing our waste streams and creating compost and putting that on the soil actually has this cascade of measurable benefits. It just gets more and more exciting. But now you got to remember who I am. I'm out in Marin, and the big question is, yeah, but will it work on a real ranch? So I'm not a real rancher. We found that out early. Well, let's go to it. We organized and we went out on 3 real ranches. We went to the Point Reyes Blue Cheese Dairy, the Nicasio Valley Cheese Farm, and the Bivalve Dairy in Point Reyes Station. We did exactly the same research, except we added it up. We added in an additional carbon-nitrogen ratio compost plus a manure, replicated 3 times with controls. And what was important about this research now is it shows us that there were 3 different grazing managements. There's one fixed stocking. Randy LaFranchi puts his cows in there 365 days of the year. Bob Giacomini brings his replacement heifers in his paddock for about 6 months, and John Taylor puts them in for about 2 weeks. So we have 3 completely different grazing pressures. Same exact compost was applied, and this was a locally sourced one, and this had animal waste in it as well, and we're seeing similar results. This paper is still being processed and reviewed, but the scientists are very excited that the thing works in the real world. So one of the other things we needed to do was conduct a full life cycle assessment. So we started making our own compost where the scientists were able to then measure and monitor the greenhouse gas emissions from all the different ingredients and then the resulting compost. This peer-reviewed, published life cycle assessment shows that the fuel used to collect the compost, this is we're expanding to the Sacramento source. We also looked at that, and this is Dr. Marcia DeLange's work. Collection, transportation, composting, hauling, distribution, enteric fermentation from the grazing animals, soil system respiration. The net climate benefit for that transported compost to my ranch is so huge compared to the emissions, it's well worth doing. So it's a very exciting thing. And that's the first year. And then from then on, it just gets better and better and better from that single bump. Our research has produced over a dozen peer-reviewed published papers. And we actually have the protocol for this, and I'll talk about that in a second, for carbon credit trading. So our next scientific questions are, based on this understanding, what does this mean globally? So we've developed a strategy, our team of scientists has gathered, and there's a global circulation model. It's a tool that scientists can use, and they can look at what land masses on Earth can be managed what ways to have a global impact. And our team is currently funded and working on that at Lawrence Berkeley Lab. What's important about that is the author of that model is an IPCC scientist. It's Dr. Bill Collins. So the results of this work, and he's very excited because he's created a new module that accounts for human behavior change and these land management practices, and their team is very excited. The other day I got a very excited call from Dr. Silver saying as they were entering the data for this new model run, they all started smiling because they realized this is the first time they've entered solutions into a global circulation model. And the results are very promising. Yeah, very exciting. Thank you. So then the other question is, what's the highest, first, and best use of these organic feedstocks based on season and place? Is it biochar? Is it incineration? Is it mummification in landfills? Is it composting? These other processes. So we need to develop the process to be able to determine first, highest, and best use of organic waste streams. So we're organizing around that now. And then the current research that's happening on the LaFranchi Dairy in Nicasio is looking at first principles of composting. We've been gifted a grant from the Schmidt Family Foundation to pay for an $85,000 laser that has 16 ports that gets instantaneous full-time greenhouse gas emissions from composting. And we'll be able to now look at how they currently make compost as per Cal Recycle specification, and then start modifying the formulation and the management practices to minimize greenhouse gas emissions and hopefully VOCs, and maximize soil carbon sequestration from that. And then the other research project that's currently happening, and I'll go into a little detail on this one, what are the other feedstocks available for composting? And we'll talk about human waste here in a moment. And then the fifth area that we've identified, what is the measurement and what is the modeling and different mapping exercises? And this is where Project Drawdown is so important. That's the structure that they can provide for us. How do we look and compare at all the different strategies being considered and find the best strategy going forward as a global community? So, as I said, we've organized at the Nicasio Dairy. This is Dr. Silver and the compost operator and Dr. Creek. And this is to answer the question, will we have enough compost? So early on, Peggy and I got quite excited. We'd attended a permaculture class out in Bolinas and read this book, Humanure, the Humanure Handbook. And so reading that, you appreciate that potentially human waste is this very valuable, underutilized resource. So being who I am, I really like to work with existing infrastructure. Everything I do has to be replicable, scalable, and broadly applicable, and we rely on science. So we convened a conversation with the state of California. Reinhard Holwein is here in the room from Cal Recycle. The County of Marin Health Department came, and we discussed what it would take to do a responsible research inquiry into composting human waste. And the first round was called McPoop. And that didn't last long. The scientists couldn't quite do that. But the thinking here was, if we could we compost human waste and destroy pathogens? And this was what was put forth from our agency conversations. It had to have public safety at the forefront. And so the biggest concern about human waste is pathogens. So with a little bit of exploration, we determined that the vault toilets in the National Seashore were the best source for human waste because they can't use water, which dilutes human waste 600 times, and they can't use chemicals, which would have confounded our research. And with 2.5 million visitors a year, this is a true cosmopolitan sampling. So we found vault toilets, and we hauled the material from them, and the Park Service is very excited, and even if we solve for composting dog waste, that would be a win for them, and we could talk about that later. But we organized a research project on my ranch where we took the human waste, and we designed a set of cells based on Joe Jenkins' model, where we took hay bales, and we put this human waste compost in these cells. And this is the world's most sophisticated research facility. It's got full-time measurement of oxygen, moisture, temperature. We're using the phyllochip technology. College of Marin provided a lot of the student power to do the research. And we began a series of experiments looking at the pathogen destruction of thermophilic composting of human waste. And we were also able to put a pipe in these different research cells and monitor the greenhouse gas emissions, mid-pile and externally. And so human waste compost, it's very easy to compost, and we were able to achieve scary high temperatures. It actually got up to 181 degrees just within a week, and it maintained that temperature. Now, what's important here is that the lead scientist is Dr. Gary Anderson, and this little handheld gadget, this is a credit card size thing, but inside that window, that little half-inch square, this microarray has 1.1 million programmable sites for the DNA of all bacteria and archaea on Earth. This is what NASA uses for outbound spacecraft. We're deploying this technology on human waste and showing what happens during the thermophilic compost process. We know what organisms were in there to start with, and we were able to watch the different pulses of populations and see the resurgence of beneficial organisms afterwards. And there was an associated temperature log with that. So basically it worked. We were able to destroy pathogens in human waste within just a few days with thermophilic composting as per Cal Recycle specification. The website is thermopileproject.org. That was phase one. It was quite successful. It also birthed a couple other things, which seems to be what happens to me now. I can't just do one thing. Got 5 minutes? Okay. Dr. Sasha Kramer is composting the human waste from 5,000 refugees in Haiti, and the Schmidt Family Foundation is funding her as well in their work. And they asked us whether we could help her determine the safety of that process. In order to do that, we had to develop a field DNA extraction kit, and that's $1,400, and it looks like that. And what we were able to demonstrate by getting the volunteers from the Schmidt Family Foundation to come to my ranch, we taught that team how to do field DNA extraction in order to then test for using the phyllo chip for pathogen destruction. And it works, and it's quite successful. The next thing we're able to ask now is, can we deactivate or deal with pharmaceuticals? So our next phase, which is currently happening, we're looking at ibuprofen and Cipro, and we've been composting that now for several weeks. And we did that by putting these boluses of that compost saturated with those two pharmaceuticals, and the early results are quite exciting. After that, we'll be looking at hormones and endocrine disruptors and estrogenification properties of different pharmaceuticals. But will it scale? This is the big question, and that was asked earlier here. So not just the compost of human waste, but the overall package. Will it scale? To that end, in December of last year, we were invited and participated in a conversation that the California Department of Food and Agriculture and the California Farm Bureau asked us to attend. Was the Marin Carbon Project ready for prime time in some respect? The challenge here is that the agricultural community did not want to be a regulated sector in California under AB 32. And could we show that agriculture had the promise to be a climate beneficial solution to the other issues? So we collaborated with the team at Colorado State University and created the COMET Planner, which is a USDA online tool that brings together 35 practices that the USDA recognizes as climate beneficial, either in terms of soil carbon building or in greenhouse gas benefits. This online tool has now enabled us to have taken the Marin Carbon Project to scale in our community. And using this resource, we've now reached out to our local community, and we've expanded, and we're at full-scale demonstration now, and many landowners have signed up to participate as demonstration sites for carbon farming. So much more than just compost application. We recognize that riparian restoration, windbreaks, hedgerows, the type of plant, the grazing management, all of these factors play into what could ultimately be seen as a carbon farm to produce food, fuel, fiber, and flora. We settled on 3 of them. Stemple Creek is a great example. They're now providing the food for the Perennial restaurant in San Francisco, which closes a much bigger loop. This is Lauren Poncho on his landscape there. And then in terms of the measure, map, model, monitor, and manage question, we basically had to determine what method of measurement will give us the kind of data that we need to support management decisions in carbon markets. So we're ranging from a molecular level all the way up to remote sensing from satellite imagery. We're collaborating with UC Davis and several soil scientists, and we've deployed all the different measurement methodologies from the most sophisticated to the simplest on the same site. And with that exercise, we'll be able to determine what type of soil sampling we need. And that will only be a period of time when we have enough samples then that the models will have enough certainty that we can do this all through modeling, which saves a tremendous amount of resources. We also were able to go full scale. So on the Stemple Creek Ranch, the Strauss Dairy, and the Corda Dairy, we got thousands of yards of compost out over a year ago. And in that exercise, we were able to split the fields, and now we can test, will quarter-inch and half-inch do the same thing? Using the NDVI spectrum with remote sensing, we actually saw an early signal that the quarter-inch did have the same biomass response. That was a very interesting thing. For years now, we've been going to Sacramento, we've been walking the halls, and that has resulted in successful legislation on so many levels, and that's a whole conversation there. This was a meeting where the Bay Area Air Quality Management District came and looked at our test plots. And as a result of that meeting, our protocol for compost application on grazed rangelands has been approved for CEQA mitigation. So we can now trade carbon credits on this. And then further, this is the State California Coastal Commission. They visited our sites, and as a result of that, they gave us millions of dollars for all of the RCDs in the Bay Area to create carbon farm plans. And the idea here is that having these shovel-ready projects organized on the ground, when climate dollars do come, and they will, that will be the implementation money for these large-scale projects. This is a meeting where the governor sent his task force to our ranch, and the result of that in November, the following month, we heard about healthy soils in his budget as one of 5 pillars of his climate solution strategy. So it's pretty good. That's my time. I could talk all day. I just want to summarize food, fuel, fiber, and flora. This is how we interpret the production of sugar, starches, and cellulose, the products of photosynthesis. The Fibershed project is amazing and successful. I would encourage you to look at that. And what I brought, so this is a I guess a pilot pair. This is locally grown organic cotton, indigo plant pigment rather than the coal tar blue that we use. And by working with lights. And this is a hoodie. North Face made 5,000 of these climate beneficial hoodies for us last December. This is locally grown cotton. The color is from plants and natural pigments. The other pants I'm wearing are oak galls and rusty nails.
Just show us the back.
Yeah. So the point is this: we can look to the production of the solution for our material cultural needs through restorative agriculture in a way that globally could actually rebalance the carbon cycle, and we could look good doing it and have fun. That's all I know.
So we're going to do a short 4-minute film called The Soil Story. And this is by Kiss the Ground. So I want you to share. This just came out, and the person who did The Soil Story is, the Story of Stuff, Lewis Fox. And he was one that produced that, did The Soil Story. So, and then we'll take questions after this. Wait a second. What's going on here?
Do you feel hopeless about climate change and the damage we are doing to our planet? I did. But then I was shown a new way to look at the problem, which made the solution so obvious and so within reach. A solution that's right under our feet. Climate change is all about too much carbon in our atmosphere. But carbon's not our enemy. It's the building block of life. Everything alive is made of it. It's us. The problem and the solution are simply a matter of balance. Let's step back and look at the 5 pools of where carbon is stored on planet Earth. Starting about 500 million years ago, when plants appeared on land, carbon began to cycle in an amazing balance, a balance that allowed for life as we know it to evolve. Then one life form, us, figured out how to extract carbon from the fossil pool. Then we burned it for energy, putting it into play, disrupting that balance. The way we manage land and do agriculture is moving even more carbon from the soil and biosphere into the atmosphere. Specifically, we've moved 880 gigatons of carbon dioxide into the atmosphere, which is heating up the planet and destabilizing our climate. Now, the oceans have absorbed a lot of this excess carbon, which is resulting in ocean acidification and accelerating a mass extinction of sea life. So in order to save life as we know it, of course, we have to stop releasing fossil carbon. The big question is, where do we put this excess carbon to get this cycle back into balance? Well, remember when I said that the solution is right under our feet? It literally is. It's the soil. Plants, with sunlight and water, perform photosynthesis. They pull in carbon from the air and turn it into carbohydrates, sugars. Then they pump some of those sugars down through their roots to feed microorganisms who use that carbon to build soil. Voila, carbon moved. Plants pump it in and soil stores it. Nature's living technology is amazing. Scientists have recently discovered that applying a thin layer of compost sets up an ongoing positive feedback loop that brings more and more carbon into the soil each year. In concert with other regenerative practices like not tilling the soil, planting trees, cover crops, and planned grazing, we can build and retain gigatons of soil carbon. This is carbon farming. This is regenerative agriculture. And there is nothing more powerful than an idea whose time has come. Unlike more carbon in the atmosphere, more carbon in the ground is good for us. It makes healthy soil, which is nutrient rich, full of life, and holds way more water. This means more nutritious food and crops that are more resilient in the face of drought. That's good news for farmers, families, and everyone that eats. Remember this: the way we grow our food, fiber, and fuel either puts carbon up into the atmosphere or it pulls it down into the ground. The regeneration of soil is the task of our generation. Our health, the health of our soils, and the health of our planet are one and the same.
So really appreciate people can go ahead and share that at the soilstory.com and put that out on social media. So we'll take some questions now. Let's see here. Right here.
I'm wondering about the application of compost. And did you try using compost brewed, compost tea instead of compost?
Great question. So did everyone understand that?
Come right here.
Oh. So what's the difference between compost and compost tea? Is that about it?
Did you use compost tea?
Yeah. So, yeah, I did. And so on another experiment entirely, I put compost tea that Elaine Ingham helped us produce. We sent soil samples and determined what we were trying to achieve there. And I didn't see on my research plots any difference between the treated or untreated compost tea plot. And when Dr. Silver and Dr. Creek weighed in on it, Jeff said simply, well, yeah, you just fed lunch to your native population. The difference between compost and compost tea for our purposes is to also provide the substrate that those organisms are on. And so our compost also acclimated on our ranch prior to application. So there was probably a native population of organisms present in that material.
You gotta speak a little louder too.
Okay.
How many head of cows did you bring out to your ranch? And how long were they on your pasture?
Okay.
You said you had 50,000 pounds of
Yeah.
gain.
So the question was how many animals and how long they were. So remember, I'm not a real rancher. So when I'm holding a gate ape open and 250 animals walk past me, I say that's 250 head. Whereas a rancher counts a cow and a calf as one head. So there were 250 animals walking through, right? And so I have 67 breaks that I've established. And some of them, the cows are there for 2 hours, some of them for a couple of days. And the total duration is 5 weeks. But what's important here is, and I missed this entirely, but Dr. Creek helped me understand that during the growing phase of a plant, if a cow is allowed to revisit that plant after that first bite, the plant suffers from that after the third day. Normally, and what I watched was the cows really do walk across the landscape. They want that first top bite, which is sugar rich. The further down they go, the higher the protein, then they get diarrhea and pink eye and other things. So by holding them on a field, you actually force them. They need 30,000 meaningful bites of food a day. They have to have them. Otherwise, their digestive tract goes into duress. So by being on my game, I'm always opening fresh pasture for them and moving them through the system where they're getting that peak fertility and most excited. Later in the year, in these annually dominated systems, the grass does dry, but it happens gradually, and the organisms in their gut change so that they're adapted to that drier food. So it's an art.
Let's try to keep it a little quicker.
I have to shorten it, sorry.
Hi, have you introduced plastic into your compost to see if there's any effect?
I don't even...
Have you introduced plastic into your compost?
How and why would you do that?
He's not using plastic in his compost.
I'm not using compost as plastic, or plastic as compost, but to introduce plastic into the compost to see if the compost will digest the plastic.
Research-wise. Oh, you're talking about compost? No, my strategy would be to go upstream and stop plastic being produced.
Fair enough.
Yeah, I'm beginning to get this, I've heard it enough times, but I'm wondering, do we know what the impact of this carbon sequestration will be on the oceans? Is there any
Yeah.
information about how quickly they might respond or how?
Yeah, there's certain organizations like Oceana that are studying this, but the main thing they're saying is we have too much carbon in the oceans.
Right.
And so some people have told that the oceans can start to naturally come back in balance, but I'm not an ocean scientist, so I don't have the exact information. But that's we got to just stop putting more carbon into the atmosphere and pull it down.
Yeah, I'm just wondering if
Yeah.
it'll come out.
So can we just tag on
Yeah.
that? My understanding is that the ocean and the atmosphere are in a dance, and they're always in balance. By removing carbon from the atmosphere, the ocean should release it.
Okay, thanks.
Yeah.
What information can I refer farmers in the Mid-Atlantic area, because it's a very different climate?
NRCS, right?
Yeah, so I said earlier, is my preference to work with existing infrastructure, and that's expressed in agricultural systems through the USDA. And in every county in America, there is a resource conservation district which collaborates with the Natural Resource Conservation Service. And so Farm Bill funding hits the ground through those organizations. Ask them to ask or request for carbon farm plans, and we're trying to put pressure to get those national.
From NRCS.
I saw the charts, and it looked to me like a lot of that, most of that carbon was pretty close to the surface of the Earth, the one I saw, and I heard you mention that this is in Mediterranean climates, so there's been some questions about the wisdom of trying to put a lot of carbon on the surface of the Earth in California with this Mediterranean climate, knowing that through the last 100 years, all these areas have burned several times by lightning or whatever cause, and just a matter of time before they're going to burn. And they burn to quote-unquote bare mineral soil in some cases. So my question is, have you thought about whether a fire or two will undo everything you're doing in your field?
I haven't thought about it, but I will tell you what I think right now on the spot. We looked at the durable forms that are in the ground. So the recalcitrant fractions are pretty much fireproof. So if the above ground vegetation burns off, that's a net carbon zero. That's mostly labile. And then any litter that might be on the surface, is that what you're describing?
Just carbon in general?
Carbon, yeah, I think it would be a net carbon benefit to put compost on grazed rangeland systems in California, even with fire. We could talk offline if you want.
I'm understanding this to be happening in a grazing, ranching situation. So in terms of farming and producing produce or something, does it translate, or the plants are there and it doesn't translate? What's the relationship there?
Go. Yeah.
So we were intentional looking at rangelands. I didn't want to get stepped on by Monsanto. And so nobody's out in the rangeland system putting anything out there. By definition, the minute you irrigate it, fertilize it, or plant into it, it becomes pasture. And so we were purely looking at a system that nobody was in to see if we could deploy something globally that could reverse the climate crisis. The idea here is that by understanding in depth the mechanism that we're working with, other people could get inspired and then take that mechanism into other systems. And that seems to be happening.
And compost, the benefit besides just the carbon is you're going to have more nutrients in the soil, and you're going to conserve water, and you need less water. You don't have to pump water. You don't need to pay for all the electrical bills for that.
Or the carbon.
Or the carbon, yeah.
You talked about occluded light fraction carbon versus heavy carbon. Could you just
Yeah, so I think most of us are familiar with humus, and that's the occluded light fraction. It's physically protected carbon, it's sticky, and it also starts to associate with the minerals in the soil. That's the physically protected carbon. The heavy fraction is actually when it is armored up with minerals, where it's inside of a clay particle.
I'm wondering, this is kind of the elephant in the room, I'm going to say it anyway. I'm wondering if there's any interest or discussion, both with the ocean and with the compost and land, to administer zeolite to ameliorate some of the effects of the radiation coming over from Fukushima.
Got me there.
I will hope you look into it.
What is zeolite?
Zeolite pulls out radiation.
It's a volcanic earth
It's
mineral.
a volcanic
that has
earth
a high
mineral that is
CaC
very,
ratio.
very
It acts
powerful.
like
They did it in Chernobyl.
That's
Nobody's
processing.
talking about it here, and I'm hoping in presenting this to you guys, it'll pique your interest because
So-
300,000 tons of nuclear waste is pouring into the ocean every single day, and all of the holding tanks in Fukushima have now been, destroyed through the latest typhoon, and we're being hit, and it's showing up in the milk in Minnesota. So, we're getting it the worst here, and this is a very powerful antidote for radiation, both in our food and air.
So we'll research that. I know Fukushima is a major issue.
Thank you.
Thanks.
What does your farm pasture, what does your ranch pasture look like right now?
Oh, it's a wonderfully woolly mess.
Is it green or brown?
If you look below the thatch, you'll find the green. It was very important. I actually called off the grazing this year. The cows the truck was scheduled. This was my best year ever for native seed production. And I called off the grazing because I wanted to let all the seeds produce, and I'm so glad. But it's a really messy looking ranch right now, and I couldn't be happier.
This is just a logistical question, but what happens when you have these cattle for 5 weeks and then they go to another farm, or what's the system there?
Okay. So in reality, most grazers have to feed animals 365 days of the year. So there are several strategies to do that. And if I were to choose to graze animals around the year, I would bring in a small herd, probably 25. And every year I would establish a pattern of grazing where in the winter they ended up on rocky soil. I do have haying equipment. I can bale my native grass hay, and they really love it. So the idea and the strategy is to serve my nutrients up on rocky ridges in the winter and manage the system that way. Yeah.
Do you guys have a go-to source for how much energy it takes to get carbon into soil through biochar versus?
The biochar question. I was advised that is someone else's work because I have really strong opinions. On a planet that's heating up, burning things is not indicated.
Yeah, biochar is a little controversy. I mean, I have some people that I know that are opposed to biochar. And other people feel, it's site specific and it can offer some good benefit. And I know people work in permaculture in like Indonesia, and biochar is a very important element in their forest reforestation projects, and produces a lot of positive byproducts. So.
Yeah. That didn't satisfy you, I know. And why don't you find me after and we'll talk in depth, and I'll show you the research papers about biochar I'm aware of.
I just recently rode my bike across the country and was optimistic riding down Slings Valley, looking at the agriculture there, figuring that we could do something to change carbon through sequestration in agriculture. But when I got in the Midwest and I looked at those cornfields that went on the states, days and days of that, I become somewhat despondent. We could actually change that system of agriculture and still feed the people that we're feeding. Is there, your process can take the carbon out of the atmosphere. Can we do that and still maintain or, feed people on the earth there somehow?
Yeah.
Short term?
So first off, we have to stop buying products from industrial corn and soy. That's and we have to educate people. I think 5% of all land in the United States is for corn. It's a death sentence. Corn and soy, the way we're growing. So we have to do that, and also those same soy and corn farmers can grow, winter cover crops and make a small improvement just by doing that. And they can add, they could be growing hemp in rotation and peas and lentils. So we need to add more rotation crops. And at some point, if there's enough demand for pasture-based meat, that some of these farmers can just stop growing corn and soy and do pasture-based systems. But that's going to take some time.
I do want to add on to that, though. So the only way this is going to work is if everybody's invited into it. And so we really have to find it in our hearts and figure out a strategy where there's room for conventional ag, for, or all the different systems. Yeah, yeah. The good news here is that the political will of the Americans have been expressed, and climate is an issue, and the Farm Bill and through the USDA, that healthy soil strategy addresses this, and that's where Farm Bill funding is being directed. So it's a national campaign of healthy soils. It's a very exciting time. This is the UN Year of the Soil. This is our moment, and there's room for everyone in the tent.
And also, just have to understand, industrial agriculture actually feeds a very small portion of the population. It's not like 50 or 60 or 70%. It's less than half. And there's a lot of food waste and things just there. We need to focus on the distribution and that. So and small farmers are the backbone for the whole world for food production. We've kind of forgotten that. We kind of have a more U.S. centric view, but and that's a more complicated thing. But there's a lot of good research on that.
Yeah, I'm a small farmer up in Mendocino, and we're launching a project called Organic No-Till. We've got the website organicnotill.com, and we're wondering about strategies. We're trying to develop a model to do no-till organic farming in California in this climate, and we're wondering what strategy we should take next. Go for grants or grant funding, or try to hire a grant writer, or we're wondering what step to take next.
I would suggest is to start to learn from people who are doing that. I know somebody in Sebastopol, I think it's called Bullfrog. Singing Frog, yes. Yeah, yes. And
is Paul here?
Yeah, so they're doing really good work on that. So yeah, you might, yeah, I don't have, we can maybe talk later, but that's important to do.
What was that again?
Singing Frog, yeah. Organic no-till.
So is his.
Yeah.
So is his.
Yes, it is.
Yeah.
One of your slides mentioned ocean acidification in relation to production of oxygen. It had something to do with oxygen.
With industrial agriculture. So the ocean acidification is because of the too much carbon falling into the ocean. So the oceans and the atmosphere are full of carbon now. They're maxed out. Their carbon sinks. So now we need to put it into the soil. Well, it's also there's lowering of oxygen as well because of the cutting of forests, and also that's the other thing I didn't mention. There's a lot of things you can mention in this talk. The plankton, 2/3 of the oxygen in the planet is from plankton. So we're seeing about 1% of the plankton I think is dying a year right now. So we're seeing a reduction in oxygen. That's going to be definitely going to be an issue for humanity as in the planet is we're going to have low levels of oxygen going forward unless we change things.
There's also research showing that increased CO2 levels cause us to have all kinds of complications. It's hard to think.
Yeah. Yeah. You think? Are we not thinking so clearly sometimes? Speak for yourself. No, just.
Can you just outline the stances of Bernie and Hillary with anything they've said?
Oh, about Bernie and Hillary. So actually, Bernie was the first president that talked about ocean acidification. So that's good. Bernie's more he's an economic progressive, not so much a wide on the environment. That's one of the criticisms from the environmental movement right now, but much better. And he talks about climate change as a real issue. I mean, Hillary is going to appoint whoever Monsanto suggests for Department of Agriculture and whatever the frackers want for the Secretary of Interior. Let's be real. Yeah.
More questions.
Yeah, just a couple more questions.
In terms of like practitioners and people getting in the field to help scale this work, what do you see as like missing skill sets or for young folks stepping into this? What's needed?
You want to take that?
So in Marin County,
what's missing?
Yeah, what's missing? How can we roll this out and include everyone, including young people? Marin County has a wonderful organic garden or farm at the junior college. The conversation right now, and I saw someone from North Bay Conservation Corps. Yay, there she is. So that's the conversation. How do we start connecting with our existing infrastructure? You guys, this thing is built. We lost the manual, we backed into a corner. Everything's in place. We're ready to roll. We just need to organize and put our priorities straight. We have a beautiful education system. We have wonderful people. All the right people are all in the right places. We just need to have a couple more conversations and this will happen.
And also just want to add is more, more storytellers, and also social media is very important. Creating the right kind of click candy so people will do that. So that's really important. Regeneration International, Kiss the Ground. These are some of the organizations. Carbon Underground that you can work on.
There's one big question there.
Right there.
I just want to say to the person who asked, thank you for asking. And I think that more than anything, what we see right now is that people who let their governing bodies know that they want compost in their communities and that they want money for healthy soils, or that agriculture is part of their solution, we're seeing incredible traction from that. So just letting your people know in your communities, this is the infrastructure we're talking about. So we're working within our existing democratic infrastructure. The city colleges, your local council, and the state are all incredibly important voices to hear from you.
I appreciate that. We just lost Sonoma Compost in Sonoma County. So.
Yeah, I know it's a travesty.
But I'm working with Will, and great things are going to come from that.
Yeah.
So I have one more. We have one more question, and I'm going to ask it.
Okay.
Would you guys please have fun doing what you're doing? Really, we're going to do this. So let's relax. Let's enjoy it.